Alrighty then, so one of the most important things that we have left to look at, we've looked at how to process input. Alright, we can take input both from just inside a piece of code and from the user. We've looked at how to process output. Almost entirely our output has been through print statements, right? We've been printing some form of thing. That's not going to change anytime soon. And we have started to introduce the concept of a function. Most of the magic is going to start happening in the function stage, so we're going to see function and output and input. In these early levels, they sort of blend. They blend together. So, what are most of our functions going to be? Straight up, our functions are going to be math. And specifically, they're going to be arithmetic. So we've got to look at some basic Python arithmetic. Basic Python arithmetic. Mostly our concern, I'm going to assume all of you know what addition is and how it works. Addition is notated exactly as you might hope in Python, as is subtraction, x minus y. This is one of the reasons why people like subtraction, like Python as a language, because it makes a relative amount of sense. Multiplication is done using the asterisk on your computer. X asterisk y is multiplication. Division uses this symbol. And exponentiation, which is going to be very useful. Sorry, it's going for a star there. There we are. Exponentiation. Exponent. Also, last but not least, mod. Oh, I believe also this notation works. But I like this double asterisk notation. It helps. It's right in line with the multiplication as well. X mod y. We've already been introduced to mod. You'll see the fact that mod is built in as a basic arithmetic operator is a big sign that mod is important in computers, and that would be correct. So remember, modulo is the remainder after x is divided by y. So that's our basic, that's the basic set of tools that we're going to use to construct our functions. The first thing that we're going to try and generate, though, is not some regular function. It's going to be some sort of basic infinite loop. The reason for this is it sort of illustrates the power of computing. We can use a very small amount of code to generate a huge amount of information, and that's going to be a massive advantage. Often we're going to want our code not to be infinite, but infinite code serves as a good basic, or potentially infinite code serves as a good basis. So, basic infinite loops. We're going to use while. A equals 0, b equals 1. While is a form of loop that functions like this. While a is less than b, perform the following action. Note all of this is required in the syntax. This is some sort of function. Here we're going to take our value for a and add b to it, and then we are going to print x. Practically speaking, we should note that a is equal to 0 and b is equal to 1, which means that this is always going to be true, which means that this essentially reads while true, perform this action, which means that anything in here is going to loop forever. Or until, the computer runs out of memory or used up the program or whatever. So anything in here is going to loop forever. So what is actually going to occur? X is going to be set to the value of a plus b, and it's going to be printed again and again and again and again. The output for this program is then 1, 1, 1, 1, down, down forever. The reason for this is quite simple. You might have been fooled into thinking this a plus b was going to give us incrementation each time, but because a and b's value never change, right, x's value never changes. Very straightforward. This is one of the ways we can apply our basic mathematical skills to code. So this is our output for this particular program. Fear not, this still prints an infinite number of ones and can actually be a useful piece of code in general. So what we can also do is we can compare this code to this code. A equals 0, b equals 1. Got another while loop. A is less than b. Print a is equal to a plus b. Right? Sorry, this is not a thing. And then print a. This code, if you run it, a is equal to 0, b is equal to 1, a is less than b, correct. A is equal to a plus b, correct. So you're going to run this code. It's going to make a equal to a plus b, a is equal to 0, b is equal to 1. So a is equal to 1 now, because 0 plus 1 equals 1. Right? We're going to print out a, which is 1. Get our first piece of output. We're going to print out a, which is 1. Then we're going to go back into the while loop. We're going to check our condition. Is a less than b? A is equal to 1. B is equal to 1. No. And then our program stops and 1 is our only output. Right? So here, because a increments to be equal to b, the loop stops. When the condition is broken, the while loop ends. Really straightforward. So here we've got a little chunk of finite code, we got a little chunk of infinite code. Let's start trying to do something a little more functional with them. So how do we get n? How do we get n? Right? So we've managed to generate 1, 1, 1, and on forever. Right? This particular set, but what we want is n such that n is equal to 1, 2, 3, 4, etc. on forever. Right? So in a way, all we want to do is add 1 to this term, and 2 to this term, and then 3 to the next term, and on forever. So we just have to make a slight alteration to our code. As a general rule, if we have a desirable behavior, so in this case we have infinite outputs, infinite numeric outputs, and that's close to what we want over here. The numbers aren't quite right, but it's close. We should start with this code and then make basic modifications in order to actually get there. So for example, we'll see that our final code looks very similar to the code that generates all these ones. Just over here, right? A equals 0, B equals 1. Note, there's many ways to get these outputs. I'm just using the ones that I think require the fewest complicated jumps in terms of understanding what's going on. So while A is less than B, again, print B, B equals B plus 1. So in the previous piece of code, we were looking at A and printing A. Here we have a very similar piece of code, right? A is 0, B is 1, A is 0, B is 1. Well, let's see if I can get them together. Pretty close. Here, we have the same while loop, but we were printing B first, and then we're incrementing B. Here we're incrementing A first, but by B, and we're printing A. This subtle difference is going to be enough to change the entire output of our code. right? So each time we go through this loop now, because it's b that's incrementing and b that's being printed, this while loop is always maintained. First time we go through, b is equal to 1, so we get 1 as our output. Second time we go through, the loop continues to hold because a is always 0, will never be bigger than 0, while b is just going to get bigger and bigger and bigger, which is going to be the value printed out by the loop. Right, so this gets us n. Many other things get us an approximation of n. This is just one example. A slight alteration of this code, how do we get z? Right, we're looking at each particular chunk of code and we're going, gosh, how do I change this? Well, I have all these positive numbers. If I just get the negative numbers as well, then I will have all the positive numbers and all the negative numbers. Well, where's my output coming from? It's coming from this print function. So if I can get this print function to give me negative numbers as well, then I can be really happy with myself and I can have both negative and positive numbers, and all I need to do is print 0 to get all of the integers. Right? Totally acceptable. That'll get us all of our outputs that we want. Any way that gets us to our outputs is going to make us happy as a general rule in this course. So as opposed to just printing b, keep in mind I am indenting here, I'm going to print b and negative b. Ooh, I'm going to print b and negative b. Since I'm printing both b and negative b, now I'll get 1, 2, 3, 4, and I'll get negative 1, 2, 3, 4 beside it. Remember how our print statement behaves when we have variables beside it. We covered all that, right? So then I have to make sure I actually increment b equals b plus 1, or I'm not going to get my infinite output. All right, so now we run our code, and what we'll get is exactly what we expected. 1, negative 1, 2, negative 2, 3, negative 3. Forgive me, I'm trying to actually do it the way the computer would do it, where it sort of indents, though it depends on the IDE that you're running with, so forgive me if it doesn't match exactly what you see when you plug it into an IDE at home. So this is Z, and Z is a nice simple thing that we can do. Remember, we've covered all of these individually in terms of set theory, and we've done all sorts of things with them in terms of group theory. So now we're coming back, and they're very useful crutches to help us through with our computer science.